Hi, welcome to lesson 11 of arcs, sectors and angles and circles. Today we're going to look at tangents to circles. Firstly though, let's have a go at a starter question. So if you pause the video for a minute or two and have a go at these questions, please. Remember where you see the notepad and pencil icon to copy the notes into your jotter or complete the work into your class jotter. Okay, let's look at question 1A. So here we've been asked to find the size of angle X. So in order to find X, we need to find the other internal angle of the triangle. So along the bottom of the triangle, we have a straight angle. So we can do 180, take away 129 degrees, and that gives us 51 degrees for the other internal angle of the right-angled triangle. Once we know the 51 degrees, we can add that to the right angle, and that gives us a total of 141 degrees. So we want to find how many degrees are left out of the 180 that total the triangle. So we do 180, take away 141, and that equals 39 degrees. If we look at example B, again we have another right angle triangle and we want to find the size of X. So this time we add the 90 degrees and the 48 degrees to give us 138 degrees and take this away from 180 degrees. So we find that X is equal to 42 degrees. For question 2, we have two right-angled triangles again. We know two sides of each triangle and we want to find the length of the third side. So again, these are Pythagoras questions. Our decision is it the add version of Pythagoras or the subtract version of Pythagoras? So let's look at A. We have the right angle here. The hypotenuse has X on it, so X is the longest side, so we need to use the add version of Pythagoras. Filling in our values, we get X squared equals 84 squared plus 73 squared, which is 12,385, and then don't forget to square root this answer, so X is 111.29 metres. If we look at example B, across from the right angle we have 59 millimetres, so we know the hypotenuse, so X is one of the shorter sides, which means we use the subtract version of Pythagoras. Filling in our values, X squared is 59 squared, take away 46 squared. That's 1,365. If we square that answer, then we get 36.95 millimetres for the length of X. Okay, let's have a look at today's lesson then. So today we're looking at tangents to circles. We're going to be finding the unknown angles and lengths formed by tangents to circles. So by the end of the lesson today, we should be able to know the meaning of the term tangent, be able to identify a tangent and apply tangent properties to circles and use them to find the unknown angles and lengths. So let's have a look at our first note. Please copy this into your notes jotter. So firstly, what is a tangent? A tangent is a line that touches the circumference of a circle at one point only. So if we look at the diagram, AB and CD are examples of tangents. So they touch the circumference at one point only. A tangent makes a right angle with a radius or diameter at the point of contact. So if we draw in the radii, we can see that we create right angles with the tangent. Now we can complete a right-angled triangle. So tangents can make right-angled triangles with a radius or a diameter. So these are the things that we need to remember when we're dealing with tangents to circles. Let's have a look at some examples. So here, which of the lines are tangents to circles? So remember, a tangent touches the circle at one point only. The black line is not because it cuts the circumference twice. The red line is not a tangent because it also cuts the circumference twice. We have another line there, the green line, which is actually passing through the centre, but it cuts the circumference twice, so it is not a tangent. Lastly, if we extended the white line, it would actually go past the circle. It wouldn't actually touch the circle at all. So the white line is not a tangent. That leaves the pink line and the yellow line are both tangents to this circle. So let's look at some examples where we're actually using this information. So we're told that CD is a tangent to the circle. In A, we want to calculate the size of P, and in B, we want to calculate the size of angle COD. Now, firstly, if it tells you in the question that you have a tangent, then the first thing to do is draw in the right angles. So we mark them on our diagrams. So let's look specifically at example A. We want to find the size of angle P. So we are just using the fact that three angles in a triangle add up to 180 degrees. So if we add the 90 and 33 together, we get 123 degrees. Take this away from 180 degrees, and that leaves us with 57 degrees for P. If we look at example B now, we want to calculate the size of angle COD. But if we look at the diagram, COD is actually a total of angle Q and angle R. So we find these separately first. So to find angle Q, let's focus on the triangle on the left-hand side. We add the 90 and the 29 together to get 119 degrees and take that away from 180 degrees to get 61 degrees for Q. We do exactly the same for R, focusing on the triangle on the right-hand side. So we do 90 plus 45 is 135 degrees. Take this away from 180, and that leaves us with another 45 degrees. So to get angle COD, we need to add those two values together, and that gives us a total of 106 degrees for angle COD. Let's look at a second example here. Again, we're told CD is a tangent to the circle, so automatically fill in the right angle. This time we're being asked to calculate the size of angle S and angle T. Before we can calculate the size of angle S, we need to work out the missing angles in triangle DOE. Now, the important thing that we realise in this question is that OD and OE are both radii. So therefore, triangle DOE is an isosceles triangle, which means we have two equal sides and therefore two equal angles. So we can fill in 18 degrees at angle ODE also. Our next step would be to get the missing angle at vertex O. So angle DOE. To do this, we add the two 18s together to get 36 degrees. Take it away from 180. So angle DOE is 144 degrees. If we fill that in the diagram, that gives us more information. Now we can get angle S. Now, angle S makes a straight angle with 144 degrees. So all we have to do to get angle S is do 180, take away 144, and that will give us 36 degrees. Lastly, we can now concentrate on triangle COD. We know one angle is 90 degrees, another angle is 36, so add these together to get 126 degrees. Take it away from 180 because three angles in a triangle add up to 180, and we're left with angle T equal to 54 degrees. Now we can also use Pythagoras' theorem, when we encounter tangents. So here's an example using Pythagoras. AB is a tangent to the circle, and we want to calculate the length of AB. So you're told AB is a tangent. A radius AC is also in the diagram. We know from our notes that a tangent and a radius make a right angle. So we can fill that in the diagram. That means that triangle BAC is a right-angled triangle, so that means we can use Pythagoras' theorem. So again, which version is it? So we can see across from the right angle is the hypotenuse, and we already know that's 10. So AB is one of the shorter sides, so we use the subtract version of Pythagoras here. Filling in our values, x squared equals 10 squared take away 8 squared, which gives us 36. We square root that answer, so x would be 6 millimetres. Now it's your turn. Today we're going to do it a little differently. The exercise for today's work is going to be posted separately on the posts or files. So to get today's work, please go to post or files on Teams and answer the questions in your class jotter. Remember to make sure you show all working and your answers with units, and the answers will also be there so you can check and correct your work at the end.